Good morning, student. I am Dr. Ritika, the faculty of CSC department, as an associate professor in St. Andrews Institute of Technology and Management. Today, I am going to deliver the lecture on the subject of our software engineering, which is related to our PCA 4th sem. And today we will cover the topic of our software in testing. Now, what is software testing? The testing we have covered in our previous slide. Let's take a little bit review about the testing, where testing is begun with the software engineers in early stages, but later some specialists may be involved in the testing process. So it is done correctly and can increase overall software quality of conformance by testing that the product conforms to its requirement. So it is very important to test a software because a customer, after running it many times, would finally uncover an errors. Now, introduction to quality assurance. A quality assurance is an essential activity for any business that produces products to be used by others. So, software quality assure is planned and systematic pattern of actions that are required to ensure high quality in software. So software quality assurance is composed of a variety of tasks associated with two different constituencies: the software engineers who do technical work and the SQA, that is software quality assurance group, that has responsibility for quality assurance, planning, oversight, record keeping, analysis and reporting. Now Six Sigmas. These Six Sigmas is a set of practices originally developed by Motorola to systematically improve processes by eliminating defects. So Six Sigma approaches are define, measure, analyze, improve and control. So define, determine the project goals and the requirement of customers. Measure the current performance of the process. Analyze and determine the root cause of the defects. Improve the process to eliminate defects and control the performance of the process. So these are the Six Sigma approaches: define, measure, analyze, improve and controls. Some software testing fundamentals. During software engineering activities, an engineer attempts to build software, whereas during testing activities, the intent is to demolish the software. Hence, testing is a psychology destructive rather than constructive. So, a good and successful test is one that uncover and undiscover errors. So, all the tests that are carried out should be traceable to customer requirements. At the same time, exhaustive testing is not possible. Some testing objectives. Testing is a process of executing a program with the intent of finding an error. A good test case is one that has a high probability of finding an as yet undiscovered error. A successful test is one that uncovers an as yet undiscovered error. Some common terms we have covered in our previous 2 or 3 slides also. So what are the terms? Error, faults, bugs and failures. Now testing principles also we have covered in our previous slide. So main principle is all tests should be traceable to customer requirement. Testing should be planned long before testing begin, and testing should begin in the small and progress toward testing in the large. These are the principles of our software testing. Another principles are as testing progress, focus shifts on integrated clusters of components and then the entire system. So exhaustive testing is not possible. To be more effective, testing should be conducted by an independent third party. Now, we have covered in our previous slide software testings, black box testing and white box testing. White box testing we have covered as the glass box testing. We have covered in our previous slide also. So in white box testing or glass box testing, it looks into the structural testing or glass box testing, statements path and branches which are checked for correct executions. Now, levels of software testing. The software testing is carried out at different levels through the entire software development lifecycle. So these are the different levels starting from user requirement, software specification, analysis, high level design, low level design, and then code. After coding, testing process should be started like unit testing, integration testing, functional testing, system testing, and last will be the acceptance testing. So after completion of coding, after designing of the software, we will apply some software testing processes, or we can say we apply different testing on the different modules of the software. So these are the levels of our software testing. Now in unit testing, the test cases verify the implementation of design of each software elements. In integration testing, they trace detailed design and architecture of the system, where hardware and software elements are combined and tested until the entire system has been integrated. In functional testing, it is used to exercise the code with the common input values for which the executed values are available. In system testing, it checks for system requirement. In acceptance testing, it determines if test results satisfy acceptance criteria of project stakeholders. In unit testing, it focuses the verification efforts on the smallest unit of software design, so the software component or module. Using the component level design description as a guide, important control paths are tested to uncover errors within the boundary of the module. The relative complexity of test and uncovered errors is limited by the constraint scope established for unit testing. So in the unit testing is a white box oriented, and the steps can be conducted in parallel for multiple components. Though the module interface is tested to ensure that information properly flow into and out of the program unit under test. So the local data structure is examined to ensure that data stored temporarily maintain its integrity during all steps in an algorithm execution. Some boundary conditions are tested to ensure that the module operates properly at boundaries which established to limit or restrict processes. So all independent paths or basic paths through the control structure are exercised to ensure that all statements in a module have been executed at least once, and finally all error handle paths are tested. So they follow some following different types of error which we will found during the unit testings are mixed mode operation, indirect initialization, misunderstand, or you can say incorrect arithmetic precedence, and precision's inaccuracy. So these are the different type of errors which we will found during the unit testing processes. So the one source level code has been developed, reviewed and verified for correspondence to component level design. Unit test cases design begin. A component is not a standalone program. Drivers and or stub software must be developed for each unit test. In most applications, a driver is nothing more than a main program which accepts test cases data, passes such data to the component, and prints relevant results. Here, stub serves to replace module data subroutine called by the component to be tested. A stub or a dummy subprogram uses the subroutine module's interface, may do minimal data manipulations, prints verification of entry, and returns control to the module undergoing testings. So drivers and stub represents overhead. So they both are software that must be written but that is not delivered with the final software product. So here are the some stubs and module to be tested. These are the drivers and result which is, so firstly we will start with the interface local data structure boundary conditions, independent path error handling path. After finding the error, they move to the drivers. Drivers test individual modules and in the form of stubs, and finally result to be given. Now in integration testing, the unit that otherwise seems to be working fine individually starts causing problem when integrated together. So data can be lost across an interface. One module can have an inadvertent adverse effects on another, and sub-functions when combined may not produce the desired measure functions. So individually acceptable imprecisions may be magnified to unacceptable levels. Global data structures can represent problems. So in this integration testing, it is a systematical technique for conducting the program structures while at the same time conducting tests to uncover errors associated with interfacing. So non-incremental integration, or you can say big bang approach. So it is the combination of all the components at the same time and then test the program on the whole. So this approach gives a number of errors that are difficult to isolate and trace as the whole program now is very vast. The correction of such errors seems to go into infinite loop. So they may include to top-down integration and bottom-up integrations. Also, they construct and test in small increments where errors are easily to isolate and correct, and interfaces are more likely to be tested completely, and a systematic test approach may be applied. In the top-down integration testing is an incremental approach to construct of program structure. So by moving down towards through the control hierarchy, beginning with the main control module, or you can say main program, the module subroutines, and ultimately subroutines to be main control module that are incorporated into the structure in either a depth first or breadth first manner. So here are the diagram which shows the top down integration, or the we can say top down integration testing. Now depth first integration and best first integration. In depth first integration, it would integrate all components on a major control path of the structure. So selection of a major path is somewhat arbitrary and depends on application specific characteristics. For example, selecting the left hand path component M1, M2, M5 would be integrated first, and then M2, and then further to be selected. Now then the central and right hand control path are build. But in breadth first integration, it incorporates all components directly, subordinate at each level, which moving across the structure horizontally. Components where M2, M3, M4 will be integrated first, and the next level M5, M6, and so on to be done. The integration process is performed in 5 steps. First, main control module, which is used as test driver, and stubs are substituted for all components directly subordinate to the main control module. Second, depending on the integration approach selection, subordinate stubs are replaced one at a time with actual components. Third, tests are conducted as each component is integrated. Fourth, on completion of each set of tests, another stub is replaced with the real component. Now, fifth step, regression testing may be conducted to ensure that new errors have not been introduced. So, these continuation of step 2 until the entire program structure is built. So, these are the steps to be followed during the integration testing. Now, bottom-up integration, as the name implies, it constructs and tests with atomic modules, where at component at the lower level in the program structure. So the components are integrated from the bottom up. Processing required for component subordinate to a given level is always available, and the need for step is eliminated. A bottom-up integration strategies to be implement the following steps. First, low-level components which are combined into cluster, and they perform a specific software subfunctions. A driver is written to coordinate test case inputs and outputs. The cluster is tested, drivers are removed, and clusters are combined, moving upward in the program structure. So these are the clusters which perform all the functions from MC2 to cluster level 2. So the component combined form cluster 1, 2 and 3. They are tested using a drivers. So cluster 1 and 2 are subordinate to MA, and the drivers D1, D2 are removed, and the cluster are interfaced directly to MA. And similarly, driver 3 is removed, so the 3 for cluster B3 for cluster 3 is removed prior to integration with module MB. So both MA and MB are ultimately to integrate with component MC and so on. So this is the process how we can cluster, how we can remove with the help of drivers, and how we can find out the process. In regression testing, each time a new module is added as part of integration testing, the software changes. The new data flow paths are established, new input output may occur, and new control logic is invoked. So these changes may cause problems with functions that previously worked flawlessly. So in the context of an integration test strategies, regression test is the re-execution of some subsets of tests that have already been conducted, which ensure that changes have not propagated unintended side effects. So it is the activity that help to ensure that changes do not introduce unintended behavior or additional errors. So in regression testing, they follow some different classes of test cases. First, representative samples of tests that will exercise all software functions. Additional tests which focus on software functions that are likely to be affected by the change, tests that focus on the software component that have been changed. So therefore, the regression test suite should be designed to include only those tests that address one or more classes of error in each of the major program functions. So it is impractical and inefficient to re-execute every test for every program function once a change has occurred. Next is the smoke testing. Smoke testing is not the part of your syllabus, but for your knowledge I have added the new testing is smoke testing. So smoke testing is the approach that is commonly used with shrink wrap, where software products are being developed. So they are designed as pacing mechanisms for time critical projects, which allow the stuck software team to access its projects on frequent basis. So they following some activities like components that have been translated into code are integrated into a build. A series of tests are designed to expose errors that will be key build from properly performance of its functions. So they should be in uncover or show stoppers errors. And the third is the integration build is integrated with other build and the entire product is smoke tested daily. So these are the approaches which follow top down and bottom up methods in routine, and they follow some benefits like integration risk is minimized, quality of the end product is improved, error diagnosis and correction are simplified, progression is easy to access. Now, next is the acceptance and validation testing. In this testing, one may start with validate test, where validation succeeds when software function in a manner that can be reasonably expected by the customer. So it is achieved through a series of black box tests that demonstrate conformity with requirements, which ensure all the functional requirements are satisfied, all behavior characteristics are achieved, all performance requirements are attained, documentation is correct, and other requirements are met. So it is virtually impossible for a software developer to foresee how the customer will really use a program. So, to build a software for one customer or a series of acceptance tests are conducted to enable the customer to validate all requirements. To conducted by end user rather than a software engineer, an acceptance test can range from an informal test driver to a planned and systematically executed series of tests. Now next is the alpha beta testing. The alpha beta testing is conducted by the developer side by a customer. So they are basically used for looking over the shoulders, and beta testing conducted at one or more customer side by the end user of the software. System testing is incorporated with other system elements like hardware, people, information. Series of system integration validation tests are also conducted. It is actually a series of different tests whose primary purpose is to fully exercise the computer based system, which include recovery testing, security testing, stress testing, and performance testing. In recovery testing, it is a systematic test that forces the software to fail in a variety of ways and verifies that recovery is improperly or is properly performed, where recovery includes automatic recovery, reinitialization, checkpointing, data recovery, and restart are evaluated for correctness. In security testing, it attempts to verify that protection mechanism built into a system will protect it from improper penetrations. So, in this testing, the tester plays the role of the individual who desire to penetrate the system. In stress testing, it is executed a system in a manner that demand resources in abnormal quantity, frequency or volume. So it may follow some different steps, like some special test may be designed that generate 10 interrupts per second when 1 or 2 is the average rate. Some input data rates may be increased by an order of magnitude to determine how input functions will respond. Test cases that require maximum memory and other resources are executed. These test cases may cause thrashing in virtual operating systems are designed, and they may cause excessive hunting of disk resident data are created. So essentially, testers attempt to break the program, and variation of stress tested is a technique called sensitivity testing. Now, in performance testing, it is designed to test the runtime performance of software within the content of integrated testing. They may occur throughout all steps in the testing process, and also often coupled with stress testing and require both hardware and software instrumentations. Now these are the reference. So student, it is all about our software testing, which is related to our unit 4. So testing, the topic of software testing is completed from my side. In I have covered this topic in, I think, 4 slides. So these are the reference book. You can follow the software testing topic with the help of these books also. So students, thank you very much for your kind attention. Thank you students.